Hello, welcome everyone to Trig 4.1, which is complex numbers. Now these are numbers, let's say you have never seen them before, you don't know what I is. Let's find out what complex numbers are. So up to this point you only know real numbers, so if you're given a problem like this, x squared plus 1 equals 0, you try and solve it just like you normally would. X squared to subtract 1 from both sides, you get x squared equals negative 1. Take the square root of both sides, and you get x equals the square root of negative 1. If you try and type that in your calculator, it will not give you a real answer. Depending on your calculator, it might say error, or it might say it equals I. I is square root of negative 1. So if we look at I, that is the same as square root of negative 1. And that is not a real number. So we have several types of numbers. Real, that you already know about, all the numbers you could possibly think of, positives, negatives, fractions, decimals. And now there's going to be something called imaginary. Those numbers are numbers where you can't actually do that, right, square root of negative 1, but you could solve an equation and get there. So it's an imaginary number. If we put those two numbers together, you get something called complex. A complex number is a number that has both an imaginary and a real part. So for example, a plus bi. A is the real, this is the imaginary. Alright, so let's really look quick right here. I is the square root of negative 1, which we also could say I. So if we multiply it by itself, so I'm going to take I times I, which is I squared. Square root of negative 1 times square root of negative 1, the square roots cancel out, and we're left with just negative 1. So now I'm going to take this one and multiply it by the previous to get I cubed, because it's I squared times I. So that would be negative I, and then multiply that by negative 1, or square root of negative 1, and you would get positive 1. So it kind of oscillates between the two, and then you start over with 1 times I, which is going to be I. We'll get into modulus and what all that means and how we can get there a little bit later in this section. So let's try a couple of examples here. Let's just assume you don't know anything about I and what to do. Adding and subtracting complex numbers is just like adding and subtracting numbers and terms that have variables. You can kind of treat I like a variable, even though it's not a variable anymore. It's a number. It's square root of negative 1. What I'm going to do is I'm just going to add the real parts, 3 plus 2, 5, and add the complex parts, which is negative I plus 3I, which is going to be plus 2I. You have to be careful about those negatives and positives. If you want to change them to plus and negative, you can always do that. Alright, so there's one example. Let's try one that's a little bit more tricky. Let's say it's minus. Remember, you want to minus both parts and then combine your like terms. So it's going to be 3 minus negative 2, which is 5. And then I can't do 3 minus negative I. They're not like terms. So it's just going to be minus 3I, and then it's going to be plus negative 5 plus I from here. And then you can say 5 plus negative 5 is going to be 0. That cancels out. Negative 3 plus I is negative 2I. You could leave it like that. If you want to write it as a complex number, you could also write it as 0 plus that we have the real part and the imaginary part. It doesn't make much of a difference. Alright. Now let's move on to multiplying. What happens if you multiply by just a scalar, just one term? Well, it's just like a distributive property. It works as well with complex numbers as with real numbers. So 4 times negative 2 is negative 8. 4 times 3 is 12i, and you get the plus in the middle. So there's multiplying. Now what happens if you multiply two complex numbers together? Distributive property doesn't really work here, but FOIL does. So if you remember FOIL, first outside, inside, last. So 4 times 2 is 8. 2 times 3i is 6i. Then the inside negative I times 4 is plus negative 4i. And negative I times 3i is negative 3i squared. Alright, so now let's clean this up. 8 plus 6i and negative 4i is 2i, and negative 3i squared. If you remember back to what we just did right here, I squared is negative 1. So let's really, I'll just write it over here, negative 3 times negative 1, which is going to be plus 3. And then we can combine this one and this one to make it 11 plus 2i. Alright, so there's multiplying. Now let's talk about dividing. If I want to divide these out, we don't want the I in the denominator. So what we have to do is multiply by the conjugate of the denominator. The conjugate, remember, is just this sign in between switched. So instead of saying it's 4 minus 2i, I have to multiply by 4 plus 2i. And this is something, this number 4 plus 2i, these two numbers right here are called the complex conjugate. There we go, conjugate. They are complex because of these are complex numbers from this section because they have an I. So it's the same thing as multiplying by the conjugate, but now we call it the complex conjugate. And if I multiply the denominator by that, I have to multiply the numerator by the same thing as well. And now it just becomes just like the multiplying where you distribute for both of them. So let's do the top 2 times 4 is 8. And then 2 times 2 is 4i. And then 3 times 4 is going to be plus 12i, and then 3 times 2 is going to be plus 6i squared. And then that's going to be, denominator is going to be 4 times 4 is 16. 4 times 2i is plus 8i minus 8i for the inside, and then the last is going to be minus 4i squared. What should happen is these two should cancel out. That's why we're multiplying by the complex conjugate. The top, they don't necessarily have to cancel out, but the denominator should. So if I try and do I squared is negative 1, so this whole thing becomes negative 6. I'm just going to write it there so I don't have to rewrite the whole thing. 8 plus negative 6 is 2. 4i plus 12i is 16i. Alright, and then this one also, we're going to, when I add together the denominators, I squared is negative 1, so negative 4 and negative 1 is going to be plus 4. So 16 plus 4 is 20, 8i minus 8i is nothing, and we should end up with just this number. So if we clean it up, we can look at it as 2 plus 16i all over 20. Now, can I divide anything out? Yes, I can. They're all divisible by 2, so I'm just going to divide all of them by 2, and I should end up with 1 plus 8i all over 10. And that would be as simplified as it can be. There you go. All right. Now here's the last thing we're going to do. Let's say you have an equation and you want to solve it. Okay, let's use the magic X. 3 times 5 is 15, and denominator of this number is going to be negative 2. So what numbers multiply to 15 but add to negative 2? There aren't any. So we have to use a different thing. Let's use the quadratic formula. X equals plus and minus, or I'm sorry, the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. So we know that this is a, b, c. b is a negative 2. So we say x, opposite of negative 2 is positive 2, plus and minus the square root of negative 2 squared is 4, plus 4 times 3 times 5, all over 6. Okay, so now let's just simplify the best we can. X equals 2 plus and minus 4 times 15. Oops, it should be not a plus, it should be a minus there. 15 times 4 is going to be 60, so 4 minus 60 is going to be negative 56 all over 6. Now, if you remember from Algebra 2 or Algebra 1, if you got a number for this here, the discriminant was less than 0, you'd say there are no solutions. And you're right, there are no solutions. Real solutions. There are complex solutions. What we're going to do is we're going to try and get this to be a complex solution. So how can we write this as a complex number? So I'm just going to do that over here. Square root of negative 56 is going to be the same as I square root of positive 56. I just pulled the negative number out, and then we look at this and say, are there any complex, or are there any ways I can reduce this down? Are there any perfect squares that go into 56? 4 goes into 56. 4 does go into 56, right? Because 4 goes into 60, so 4 will go into 56. So I can break this down, and that should be 14. So it should be square root of 4, square root of 14. Square root of 4 is just 2, and square root of 14, are there any perfect squares that go into 14? 4, 9, no, we're done. Okay, so don't forget about the I. How you would write this would be 2i square root 14. I always goes right before the square root. So we can rewrite this as x equals 2 plus and minus 2i square root 14 all over 6. Can I divide anything out? They're all divisible by 2, so we can say x equals 1 plus and minus I square root of 14 all over 3. Alright, there are your examples. We're going to be using this in electrical wiring and resistance and all that stuff, so we're going to come prepared, be able to do some of this with some electrical questions that we will have for you. But for your assignment here today, divide 1 divided by 3 plus 2i using the complex conjugate, and then solve x squared plus negative 2x plus 2 equals 0. You're going to have to use the quadratic formula, and you're going to get a complex number. Alright, good luck.